Hmm. Good morning, respected faculty members. Good morning, sir. Dr. Sri Kalyana Jyosyula garu.
Good morning.
Good morning, sir. I'm Rajesh, Assistant Professor, Department of Civil Engineering, Kallam Harnath Reddy Institute of Technology. Let me introduce today's speaker. Dr. Kalyana Jyosyula is an Assistant Professor in the Department of Civil Engineering at Mahindra University, Hyderabad. He also serves as the co-lead for the Smart and Sustainable Materials Lab. He completed his PhD from BITS Pilani Hyderabad campus and holds an MTech and BTech degree from VR Siddhartha Engineering College, Vijayawada. He is a young member of the International Union of Laboratories and experts in construction materials, systems and structures, and represents India as a technical committee member for early age cracking of concrete and alkali activated concrete and RILEM. In 2022, Dr. Kalyana Jyosyula garu received the Young Researcher Award from STEMS Research Society in association with University Institute of Technology, Himachal Pradesh. He is a Bentley Distinguished Educator and a Construction Life Cycle Assessment Specialist from One Click. Dr. Kalyana Jyosyula is involved in multiple research projects, including 3 industrial research projects, 1 industrial consultancy project, and 1 government-funded project from DRDO with a worth of 65 lakhs. He also works as a quality consultant for several industries throughout the country. He collaborates with researchers from India, Germany, UAE, UK, Portugal, France, and Chile. Now I'll hand over this session to the today's speaker. Thank you.
Good morning, Rajesh ji, for a wonderful introduction. And I would also like to thank Dr. Satish Kumar, sir, for inviting me as a resource person for this 5-day FDP. And I also would like to thank the management of KHIT for giving me this opportunity. Give me just a second. I'll try to share the screen. So in order to ensure that the entire session runs without any disturbance, so as of now, I'm muting all the participants. Will that do good, Rajesh ji? Hello, can you hear me? You are not audible, you are on, oh, okay, 1 second. I muted everyone, sorry. Okay, so can I mute everyone?
Yeah, sir. Okay, you can mute, sir.
Okay, no problem. If there are, and dear participants, if you have any questions, please do post in the chat box. Yes, okay. Okay, fine. Okay. So hope my screen is visible to all and I'm clearly audible. Yeah, so today's session will be about parametric modeling of complicated architectural configurations using building information modeling. So to start with, I would like to thank my students. Some of the outcomes of the students have been presented here, and the session starts with the need for building information modeling, how building information modeling is currently trending across the globe, and how building information modeling can lead a path to a lot of students in terms of getting their own jobs. Not only that, it eases a lot of the consultancy's job as well, and it provides the flexibility in interlinking multiple domains together. So to start with, I will be talking about building information modeling, structural perspective through architecture. So I'll be talking about it for the first 40 to 45 minutes, and then followed by next 30-35 minutes of parametric modeling and what are the works that we are carrying out at Mahindra University. So to start with, most of us would think that building information modeling is actually architectural portion alone. And when it comes to structural analysis, structural design, estimation and costing, scheduling, sustainable design, material design, all those things, most of us will think that, okay, this is not my cup of tea and this is not the cup of building information modeling. And there is also another misconception that building information modeling is only Revit architecture. So Revit architecture is 10% of what BIM can do in terms of architectural part. But this presentation would give us an understanding that building information modeling can be used for wide variety of applications, may it be artificial intelligence, machine learning, structural health monitoring, structural analysis and design, estimation and costing, risk assessment, forensic engineering. Most of these things will be covered in building information modeling. So this is just an overview of what BIM can do, followed by how to model and what are all the various tools that we can use, right? So to start with, if you look into the current context of what BIM does, actually, when you have a model, so when you have a model, it becomes quite interesting for us to understand what all are the components of a 3D model and what do we need to do with that. So it all starts from site layout. So before entering into the process, I would like to start this BIM with something called surveying. So when you wanted to construct a building, the first and foremost important thing is surveying the land. And the land surveying is done through various techniques. Currently, we are at a stage where we have been using total station to a larger and maximum extent. So when it comes to total station application, it has got wide variety of scope. But the current generation with 21st century advancements and Industry 4.0, building information modeling through drones, we can also do surveying of land. So once we finish the surveying of land through drones, all the data points of a specific site will be stored in the cloud database. That is point number one. So now what we need to do, we need an architectural plan for the site layout that we have got through drone surveying. The advantage of drone surveying is because it is automatically linked through the cloud, what happens is all these data points can be accessed by the architect. And that interlinking or integration of drone survey data and the architectural configuration which we wanted to create is linked through building information modeling. So first step. So then architect would collect all the points that are available in the cloud and see the possibility of a best plan depending upon the Urban Development Authority guidelines or Panchayat Raj guidelines or the village guidelines with respect to setbacks, abutting roads, or the number of floors or multiple things. So that's where the architect will be able to create a plan depending upon the requirement of the client. That's the second step. Once the architectural plan is ready, it will go for the approval. So every Urban Development Authority of a given city or the Panchayat Raj will have their own means of getting the plan approved at different locations across the country. So once the plan gets approved, the important thing is the structural layout. That is, functional plan and architectural plan are ready. Now we need to target the structural plan. So if you want to get the structural plan, important thing is we need to have the configurations of beam and column, configurations of the beam and column. So once we have the configurations of the beam and column, the locations of the beam and column, then it becomes easy for us to do the structural planning. And for that to happen, we need to perform the structural analysis and design. So predominantly the two important software that are predominantly used in the country are ETABS and StatPro. So what can happen through BIM, from drone data, we have interlinked to architectural data, either it is Revit architecture or SketchUp, or there are multiple tools which are available. And then this data can be integrated to StatPro or ETABS. So you get the analysis and design results. Once we design the structure, we need to detail it. And the detailing can happen through RCDC, which is available in StatPro or ETABS. Or we can have our own tools that are developed for drafting, especially the detailing part. So that is again another integration. Once the analysis, design and detailing things are done, we will go to scheduling. Again, scheduling, we have multiple software. I will try to show it to you now. And then estimation and costing. So if you see the whole cycle, the entire cycle can happen through building information modeling. So this is how we try to initiate the understanding of building information modeling. So it's not only about architecture, but it can do multiple things. So you can see on the screen right now, a model was created and then it is idealized as a structural system. So we are trying to identify the behavior of beams, columns, slab, footing, and staircase with respect to the applied load. So load can be gravity load or lateral load in the form of earthquake or wind. So from this, using BIM, we can divide each and every component of the entire building into individual parts, like finite element method. So individual model is created, taken out, and then we perform the analysis. We try to get the stresses, strains, and deformations of a specific component alone and other building together. So this is done through finite element analysis software like ETAP, SAP, Midas, or many other tools like ANSYS or Abacus, COMSOL. There are many other tools. So which means once the model is ready with its analysis and design data, it gives us the flexibility to perform the finite element analysis also through BIM. So this is a basic introduction of what it can do. And let us say if the stresses or the strains or the displacements are not within the limits as specified by the Bureau of Indian Standards corresponding to design or earthquake or wind, you can update the changes. So you can modify the cross section, you can increase or decrease the length of the member under consideration, height, or introduce certain elements which are like, let us say, for example, if a building is constructed in earthquake prone region, we can introduce lateral load resisting systems. So the model will be updated, and the updated model will be again analyzed to see whether it is satisfying the requirements or not. So this is in brief. Now moving forward, before starting anything, I would always like to talk about where did we come from. So once we look into where we have come from, it's very important for us to understand the basic crux of architecture. Building information modeling, today, whatever the hoardings that we are seeing on the roads that are being shown, displayed, all the hoardings, thanks to BIM, 3D modeling, many rendering tools have come into the market. So these will help us. So if we go back, Eastman theory, it's way back in 1975 and way before that as well. So he was the first person to introduce the 3D architectural models to the society, made the mechanical parts or a building service core. So imagine, even without much of a technology, even without much information available with 3D modeling, the 3D model of a building service core was created using solid modeler by Eastman in 1975, and we are talking about 50 years back. And Braid, using Boolean operations, I'll tell you how to use these Boolean operations as well. He used BREPs and Boolean operations to create mechanical components. Today, we are modeling the same thing in AutoCAD or any other SolidWorks for our engineering graphics subject at BTech level. Students are using it. But this was existing way back in 1973. So this is not something new for us. We are trying to reinvent the past with the existing technology to replicate the beauty of civil engineering. Okay. So yeah, moving forward. So yes. So if today, in today's generation of the research or understanding the civil engineering subject, if we wanted to create such models back, it's just about the regular shapes. That the shapes are shown on the screen. Using these shapes, one could get a complete picture of whatever he or she is willing to develop in terms of a 3D model, right? So the building information modeling history goes back to constructive solid geometry. That's what we are calling it as CSG. That's what we need to understand to develop a 3D model. So you can see here, the constructive solid geometry model consists of a cylinder, block, sphere, and a plane. And we have to use certain set of operators that can be union or intersect, difference, or chamfer for a proper edge conditions. So which means we can develop a 3D model with the help of CSG model. Let us see how to do that. So you can see here, a 3D model was created using the constructive solid geometry model combinations with the help of operators. So you can see, for us to create a model, we need a door, 2 roof planes. You can see roof plane 1 here on the left-hand side and roof plane on the right-hand side. And you have a door, you have the building total, building mass, and some empty space. So basic knowledge is, if we want to create building without using any three-dimensional software, with just basic coding using CSG model, so total building is equal to building mass minus the empty space minus roof plane 1 and roof plane 2. And this is your final evaluated model. And the values in the brackets represent the dimensions of a specific building at a corresponding location. This is just nothing but coordinate system. 100, 010. We keep writing the coordinate system for a specific node or for a specific member. Let us say if this is the origin, it says first node 0, 0, 0, x0, y0, z0. Now I have moved 5 meters in x direction. That means 5, 0, 0 for the second node. And when I go up, third node, y also have moved by 4 meters. So it becomes third node, 5, 4, 0. Like that, we keep writing the dimensions corresponding to the each and every point of a 3D model. So olden days, this is what they used to do. Use constructive solid geometry to create the architectural models. Now, thanks to technology, we can save a lot of time. Now, if we want to understand the building information model, especially for parametric modeling, for the complex configurations, it is decided based on SAS framework, that is structure and architectural synergy framework. So in terms of explanation of SAS framework, it is divided into 2 parts. One is the architecture and another one is the engineering. So when we talk about architecture, it is again classified into structural melodies and structural poetry. And when it comes to engineering, structural poetry and structural analysis. So now, if you see structural melody, see the names are catchy and trending, because when we talk about melody, we generally think about a soothing music or our favorite music or favorite song or favorite hymns or favorite sounds that we come across. So they're always, give soothing atmosphere. They give fantastic understanding to our mind, and it gives a lot of relaxation. So similarly, architecture alone can create structural melodies, like beautiful configurations. See, today we are seeing rotating towers. Today we are seeing lotus-shaped structures. Today we are seeing whatever we are coming across in terms of nature, we are seeing the same shapes being used for construction. That's what I mean the melody. So the objects that are required, the configurations that are required can be fine-tuned at this step. Then we have structural poetry, where it integrates the creativity, innovation, and the artistic skills or expression. So you have imagined a shape, now you wanted to make it happen. So in order to make it happen, we need to merge multiple things to create a shape. Not only that, see today, the entire building is designed by the structural engineer, but ultimately, most of us would like the architectural part, the frontal elevation, the side elevation, the facades, because the whole civil engineering is spoken in terms of architecture right now. Because when you are buying a building or a flat in a G+50 apartment or a high-rise structure, what do we see? How beautiful is it in terms of aesthetics? And aesthetics is obtained through 2 means: external architecture and internal architecture. External architecture is done through the glass facades and the external covering agents or the systems. Internal architecture through interior design. So these two are taken care of. And then the structural analysis. So once we finalize the configuration for a building, we come through analysis. So today's topic will not cover about analysis and design. It focuses only on the architectural part and the modeling part. So what exactly is a structural melody? So I wanted to have an inclined slab. So what should I do then? So if I wanted to have an inclined slab, what is that I have to use in terms of understanding the interlinking of multiple components. So that you can see, these are all some of the components of a building, which we can merge together, move together. Dimensions can be changed to suit the needs of the client and to suit the needs of the structural engineer as well, or the structural designer. Architect and designer should go hand in hand to come out with 90% accurate building with respect to quality. Of course, material design also plays a role. BIM also can do material design in terms of sustainability. I will talk about it at the end. Yeah. So now if you can see structural melody, this is just representation of various elevations, various 3D configurations, which are merged together in terms of the dimensions. So National Building Code and the corresponding states will have their own government orders to decide upon number of floors per a particular locality and what should be the maximum dimension of individual rooms of a building. So National Building Code 2016, one could refer to that to get the complete picture of the dimensions of each and every room or each and every component that we are using in a building. So this is structural melody. So you can also see relationship between structural support and the building spatial program. So the thing is, here you can see the top elevation, the front, the top view, followed by the 3D view, the location of the columns. One of the important things in today's scenario, especially when we are trying to move towards green buildings, and especially when we are trying to move towards the sustainability, it's important for us to create circulation space as well as the functional space. Very important for a proper circulation of the wind, or for proper ventilation, or for proper living conditions. So for that, this is one such example where can you provide the columns and where can be these overhangs, what can be the dimension. As I said, analysis part, I'm not going into it, but right now I'm trying to show you some spaces at the corner of a building should be left for circulation, which gives very good ambience to the overall building. And then, of course, this is taken from one of the literature, and same things can be followed in our Indian standards also. If you want to adopt a cantilever beam or a truss, or if you want to have a non-cantilever roof or a floor beam, or if it's just a plain slab or arch or a vault, you have to follow the standard guidelines of length to depth ratio or length to thickness ratio. Yeah. So now you can see what are all various types of configurations that one could adopt while modeling any component using building information modeling. Number one, it is concentrated. If it is concentrated, you can see different types of configurations on the top of the slide. And at the bottom, you can also have triangular patterns. So this is a concentrated pattern, and this is a triangular pattern. So these are all just thumb rules for us, or ready reckoners to decide what configuration would best fit into the structure that I am planning for. Okay. And then if you also wanted to see perimeter, so you can see there, you have columns on all the corners of a building, all the edges of a building. This is one such ideal configuration, especially when we are going with tall building construction, where the columns should be closely spaced so that it could withstand earthquake and wind. Of course, tall building systems is a separate subject altogether, where we have multiple systems coming into the analysis and design, like bracing, shear wall, columns placed close to each other, outrigger systems. So many things are coming into the discussion. But this is one such understanding that when you have columns only at the periphery of the building, which are closely spaced, it's one such ideal construction for tall building or high rise. And you also have some of these other configurations, perimeter with transition at the center. And you also have uniformly distributed columns at all the locations where you feel like column positioning and columns placing plays a crucial role in analysis and design. Other ways, I'm just moving on with the slides. Different ways how we can configure diagonal two-way slab, diagonal one-way slab, parallel two-way slab. So in two-way slab also we have waffle slab or bubble deck slabs. So these slabs also could be configured depending. So see, my idea of today's talk is about, you have individual components and how BIM can be used to integrate, right? So that's what I'm talking about. So these are all, again, different configurations that we come across with respect to construction. So the bottom two are the configurations which we generally see in the flooring systems. So if you have different configurations of the floor, you have already a 3D model available for that. And for that 3D model available, you can just integrate it with the existing architectural building which you have already created. So meaning you already have got a 3D model for floor, 3D model for slab, 3D model for your elevation or beam, column and slab, beam, column and footing. What I'm trying to say is using BIM, you can call and integrate it together. That's what it can do. And for a proper stabilization of structural supports, it covers various bracing systems, as you can see on the screen. This is to control the lateral load due to wind and earthquake. Now, what is poetry? So this is for the first time we are getting introduced to a term called buildoid. So buildoid means one single unit is called a buildoid. So it can be either linear or planar. So this is the terminology that we generally see in building information modeling or architectural stuff when you're creating a 3D model. So you can see on the screen, it is required to create a 3D model for a bus shelter, right? So let me show you step-by-step process. Of course, this buildoid concept was taken from the plant architecture. You can see anticlinal and periclinal kind of models with vertical growth and how plant cell is formed. So architecture with respect to various configurations, we got it from the basic nature, that is the plant growth, right? So this is one more example of plant growth. Now I'll show you how individual plant can be merged together to form a complete buildoid. So you can see here, this is plan of a one buildoid, and this is the plan configuration of the larger family house with reception. You can see the reception at the front. And then this is a logging space, community space, life supply shop, and a school. So remember, whatever is shown on the screen is just a basic layout. Once we start giving the dimensions, then it would give an impression of, okay, this is a classroom in a school, this is the headmaster room, this is the indoor stadium for playing, outdoor stadium, courtyard. But buildoid is a representation of the basic layout of individual components of a building, right? Yeah, now you can see, this is example of structural poetry. This is a single buildoid. You can see one frame was constructed with a roof, and you can see like that, multiple frames are merged together to form a complete indoor kind of a walking stadium or an indoor sports stadium. So this is what I mean with respect to buildoid. Single buildoids are merged together to form a 3D model, which we can do it using any of the softwares. So some more examples are given here. You can see this is a single buildoid merged together, and finally this is a building. So what are we seeing right now? In order to create a complete building with all architectural elements, we start with the buildoid, we combine two buildoids, lateral growth and longitudinal growth. If you are going vertically with respect to number of floors, your vertical growth will increase. And if you are increasing laterally, lateral growth will increase, combining three buildoids. You can see the figure C. Then what? Vertical growth. First floor is done, next floor was constructed. That is vertical growth. And finally, complete building with the all architectural elements. So this makes our job simple, even if you are modeling it in any 3D model. Another example of buildoid with all main structural and architectural elements. Another example here. This is, you can use all these models for creating a 3D model in our 3D modeling software, which is linked to building information modeling. Now, what is that we are trying to see now? It talks about when exactly did this BIM start? Till now, we have seen the possibilities of using the basic fundamental tools with respect to CSG, architecture in ancient time, and some of the buildoids. Now, when it comes to BIM evolution, it was developed by Pronto. Pronto is one of the tools which is the initial approach of BIM. This was developed by a US American Dr. Patrick, and then it was extended by Sutherland, where he used computer-aided design with graphic user interface. 1963, almost 60 years ago, graphic user interface was used, and the name of the tool is Sketchpad. So like that, it kept on enhancing every year, every decade. And then came the Charles Eastman. He is the trained architect. He is the one who developed the first successful project of a 3D building model with all component in 1970s. And then it slowly, the building information modeling leap kept on enhancing every year. And this term was introduced by Nederveen and Tolman, which you can see in Automation in Construction. This article is still available. You can go and search it. Automation in Construction is the name of the journal. And building information modeling was first introduced by them. And after that, today you can see where we are living also. Tremendous growth, tremendous enhancement in terms of technology as well. Now, what is the consumption? So AEC is architecture, engineering and construction market. What is its trend in today's scenario? So global yearly construction, this is taken from American Society of Civil Engineering document, where they have a global center of excellence in computing. So I've taken this document from them. You can see that residential constructions from less than 3 trillion to almost 4 trillion in 10 years. So there is an increase of around 1 trillion residential structures in the last 10 years. And if you talk about the total structures, apart from residential, away from the like commercial or industrial building, increases up to 0.7 trillion. And infrastructural growth has also seen tremendously. So meaning total more than 11 trillion construction activities are happening in and around by 2020 per year. This is a huge number. How to do that? That's where this understanding is coming. So now the conventional traditional ways have got their own drawbacks. What are those? Paper-based documentation and communication. What's happening there? If you see the current construction process, architect will create a plan. It will be taken as a printout, analysis, design, and drawing details were given. So what will happen there is all these drawings will go to the site on paper-based, and communication also will happen through that. If at all, if there is a miscommunication, if there is an issue with the existing drawing, the construction is going to face a huge, obstruction in terms of the further progress, right? So another situation is these drawings will keep changing sometimes. Once during construction, architect might have given something and the structural designer might have given something, but on site, due to unforeseen circumstances, there might be a scenario where you have to change some locations or orientations. So if it is through paper, a lot of deliberations has to happen, and there is a chance that some mistakes also might happen. So in order to control such scenario, in order to avoid such scenario, let us see what to do. This is traditional way, and fabrication becomes too costly because of inconsistency, inaccuracy, and uncertainty in design. Right? A lot of errors are made because of changing on-site conditions. So once you change the on-site conditions, fabrication has to change. And lack of collaboration. So you see, currently as such, there is no predominant collaboration between multiple people on the site. So site engineer, design engineer, or structural designer and architect, they'll be in 3 different places, and collaboration becomes challenging. I won't say it's completely not there, but it becomes challenging and fragmented in bits and pieces. And building information in drawings. So this leads to the need of re-entering data for post-design simulation analysis. So structure has already been designed. It was proof checked. Now it's going to get implemented. But suddenly there is a requirement of understanding the behavior of elements for the designed structure. So that's what we also called as competing failure analysis, CFM, which means the structure was not constructed, but we have to know the risks associated with individual component of a structure. For that, we perform competing failure analysis. That we also call it as the risk analysis, which will give us the data like, okay, in a slab, if it is not designed, if it is not constructed properly, there might be a hairline crack because of using needle vibrator, or there might be a crack on the wall because of electrical switchboard connections installation, or if the reinforcement is not provided properly in beam and column, there might be structural cracks. So this warning will be given by competing failure mode of analysis. So what exactly is happening with respect to cost of changes at various levels. You can see the effect, cost, and effort that has been put for the building at design stage, detailing stage, construction stage, and operation stage. So what you can see now is ability to impact cost and performance. If you can see from design stage, it's too high from design to operations. Cost of design changes, you can see there, it keeps on increasing from first step to last step. Drafting centric workflow, if you're adopting drafting centric workflow, you have an increase and decrease with respect to the cost. Ultimately, the initial cost can be high, but during construction and during operation, the cost should be minimized. For that, building information modeling will help. You can see the statistics here. Initial cost is more, or initial efforts are more. Initial effect is more. But later on, once the shift is from detailing to construction or operation, this entire cost will come down. One could refer to the document as well. This is one of the interesting document with complete economics it was given. But BIM process will reduce the cost associated with construction and operation. Now, what is the modern approach? So now we have seen the traditional approach. So what is the modern approach in this 21st century? Wherein there will be an integration 24/7, 365 days between the traders, architects, the clients, engineers on the side, off the side, like planning people or estimation, costing and all, quantity surveyor, contractor, manufacturer of a component like steel manufacturing, aluminum manufacturing, glass, everything, and the owner. So all these people are discussing with each other at every given point of time through our mobile apps, or today almost everyone started using the Android mobile. And even at the village level, this BIM has gone through with respect to some apps in our basic, keyboard, keypad-based mobiles also. That's where the modern approach is moving towards. So what it does, it integrates all of them. So what is the primary question? What are the keys to successful implementation? So for that, so what is BIM? It is a design tool. Is it a database or is it a management tool? So as per our understanding and as per the technical definitions, it's the digital representation of physical and functional characteristics of a facility. So building information modeling is not architectural alone. It's not Revit architecture. It's not AutoCAD. It's not SketchUp. It's not Maya. It's not Design Studio, or it's not 3ds Max, or it's not StatPro. It's just a digital representation of physical and functional characteristics of a facility. So when I say facility, I can take a mobile. So this mobile is a facility, which means I can digitally represent the physical and functional characteristics of this mobile. Or it can be a water bottle. It can be a building. It can be a bridge. It can be a mechanical equipment. It can be an electrical circuit, anything, any facility. Digital representation of that is BIM. Now, in what context do we need to use? When there is a requirement of collaboration between multiple stakeholders of a facility, we have to use it. Okay? Yeah. So what it is now? It is an information modeling and the information management in a team environment, like all the stakeholders. So all team members work to a same standard. So this creates value from the combined efforts of people. It proposes the process, and it is helpful in implementing the existing technology. And here, most of us will think building information modeling means it is only applicable for buildings. The word building is taken as an action verb. It doesn't mean the structure. Anything which is buildable is called a building. So I hope you all understood this. And if at all, if you want to ask me any questions in the midst of presentation, please raise your hand. I'm more than happy to interrupt at any given point of time. Yes. So there are various data models that contain 3D building data or 3D building data. Any data it can be. It need not be a structure or a house or anything. It can be anything. Models with no support of behavior and multiple 2D CAD drawings can be merged together, and you can modify these drawings at any given point of time. Right? So now, what is IM? So we understood what is B, that is building. What is information modeling? It is in software engineering, It's a representation of concepts and relationships and all the operational things for a chosen field. So, which means, Acha, now what I can do, I can use BIM for any domain. So typically, BIM specifies relationship between different kinds of things and individual things also. You can share the data, you can stabilize the data, and you can organize the data in a complete organized structure with various requirements of information, right? This is taken from one of the course materials. And so it can object-oriented. So computer science students or IT students or AIML students, they'll read a subject called object-oriented programming. So building information modeling is just nothing but object-oriented data structure containing, for civil engineering application, architectural details, structural details, MEP details, and everything. So they're all merged into a single data point. So this is for our application, meaning we are using object-oriented concepts to civil engineering concept, and we are naming it as BIM, right? Okay. So now there are two types of modeling. One is parametric modeling, another one is object-oriented modeling. So one of the important aspects in BIM is the parametric modeling. That is the crux of our today's session. So what does parametric modeling mean? So this consists of geometrical definitions and that the data associated with the geometries that are chosen. So now what it does, it will also give us changing the sizes and manufacturing data also. When you're talking about manufacturing, it is associated with the material. So even the BIM will have the library of various types of materials that we can use to model, right? And at different levels, we can keep changing it. And you can export and import the objects from various other tools. Let us say, today I'm using Revit architecture for my 3D model, and I wanted to shift to Edificious, which is again another ACA-based BIM tool. But what I doubt is, I already have a preliminary model in Revit, but I wanted to continue from where I stopped in another 3D BIM model, 3D BIM software, that is Edificious. So what I can do is, thanks to existing integration techniques, I can open Edificious file. I can go to the cloud database, which is called as IFC, Industry Foundation Class. I can go there. I can call the model, which I've already created in Revit, and I can start working from the portion where I stopped it. That's the beauty of the current BIM technology that is available across the globe, right? So what I mean, I have created a door, window, and a single room in Revit architecture. Now I have to create the entire building in another tool. I have called it, I have exported it from Revit architecture through the cloud database. Now I wanted to have different shapes of windows or different textures of windows. Let us say, for example, I liked our ancient great-grandfather, grandfather type windows in my building. Somebody might have already created it in the database. So what I can do, I can go to the database, I can take that window, use it in my model. So this all looks interesting. Today, there are many tools which all of us can start using it free of cost or with some trials, which I'll be showing at the end of the session, which you yourself can explore how to experience this interconnectivity, right? And then So these parametric objects, once the product is generated, based on the user needs for a particular project, we can publish it for utility, right? Now, another thing is, it will support for project team collaboration. If you take a project, let us say, for example, I have visited L&T last year, and they have got a huge BIM facility. They have shown us statue of Unity construction, and I could see entire thing using building information modeling, virtual reality, and augmented reality. So for the project, they have a team. The entire team lead, so for example, structural team, architectural team, MEP team, planning team, and estimation and costing team, and quantity surveyor team. All the team leads are sitting in a conference hall with a big screen using the BIM app that they have developed and that they have got. Everyone is talking to the people who are working on the site virtually, which personally we can also experience. I'll also show you how the interaction can happen, right? So how it can be done? use software of the same vendor. Now let us take, for example, Autodesk. In Autodesk, we have AutoCAD, Revit architecture, and then some analysis tools like robo structural analysis. Robo analysis is one such tool given by Autodesk. Use software of the same vendor. Now, if I created a 2D plan in AutoCAD, it is easy for me to integrate to 3D Revit because it is of the same vendor. And I can use robo structural analysis software to analyze the 3D model which I have created in Revit architecture. If it is of same vendor, it is easy to use. But use software of various vendors which exchange the data using industry standard. So I have a 3D model in Revit architecture. I want to analyze and design using STAAD.Pro or ETABS. I can interlink it using some coding. That is also what some of the companies like Ramble, today they are trying to integrate different tools from different vendors using a programming language, which I will be showing in the next half an hour, called Grasshopper. Believe me, as a student, like say, for example, if a student is opting for a BIM, today there are companies which are offering 10 lakhs per annum package to a maximum of 15-20 lakhs, depending upon the experience and the knowledge that they are carrying, right? So, which means parametric modeling can happen for both same vendor and for different vendors also. So, if I am using this software's integration from architectural plan to estimation and costing from the same vendor, it is called as Open BIM. If at all, if it is called closed BIM. If the software tools are of same single vendor, it is called closed BIM. If at all, if I am using software from multiple vendors, it is called Open BIM. And if I am using single software once at a time for complete analysis and design or architecture, it is called Little BIM. If I'm happy to integrate different building models that are available from different disciplines through asset lifecycle, it is called Big BIM. Today, in 2023, the entire globe is looking towards Open BIM, right? Earlier, in the last couple of decades, we have been working on closed BIM. Today, we are looking towards Open BIM, right? Next, so what it does in general, so you can see here matrix of BIM. So Open BIM, closed BIM, and then you can see there little Open BIM, big Open BIM. So today we are at a scenario where we are focusing on, the entire globe is focusing on big Open BIM. That's where we are. So future trend is towards big Open BIM, and level of maturity also is shown, right? So how to geometrically represent and how to represent it with respect to building. Geometric representation versus building representation. So you see here in a geometric representation using BIM, we can say that it has got, okay, rectangle 1. So this entire exterior portion is rectangle 1. Interior portion is rectangle 2. Point 1, point 2. In point, what do? We have to specify the coordinate. In rectangle, we have to specify the origin, length, and width. Similarly, in BIM, you can also create 3D models with exactly similar to geometric representation. Like you can see here, 4 walls, 1 space, and 4 points. You can see how you can define the building coordinates in terms of connectivity. So wall 1, wall 2, wall 3 are connected to space 1. That's what you can see the arrow mark. Wall 2 connected to wall 1. You can see this here. And wall 3 connected to wall 2. That you can see here. And wall 3 is connected to point 3. And all the entire wall 3 is close to space 1. So this is something that we have to do with BIM, which is called as Open BIM also, right? So we can do geometrical shapes, solid modeling. So once we, I'm talking about interlinking and all, how many dimensions does BIM cover? Let us see. How many dimensions can BIM cover? First, 2D, that is geometrical shapes, 3D, that is solid modeling, and 4D. 4D covers 3D plus scheduling also. You can do scheduling parallelly, which you can create the entire schedule for the construction of a 3D model which you have developed. 5D, it is called as 3D plus scheduling, that is 4D, plus costing. You can do quantity surveying using BIM with 5D modeling. And then 6D, that is called as sustainability or energy analysis. Simple example is thermal comfort. whatever types of material which we are using in our walls, especially in places where the temperature crosses 45 degree or close to 45 degree, it is very important for us to have, today's trend is whatever might be the temperature outside, inside temperature should be somewhere around plus or minus 28 degree, 28 plus or minus 3-4. For that, we have to perform thermal analysis, energy analysis, which we can do using BIM 6D modeling. So this is what this is where we are right now, building information modeling till 6D I have shown. Now today they are developing with respect to 7D, 8D, health and safety. With respect to a movement of an individual inside a building or on the construction side, how healthy it is, how safety it is. 9D is lean construction and 10D is collaborative project. We can also integrate the contractual agreement, laws, bylaws, rules and regulations of a particular locality. Of, say, for example, I have constructed a G+5 at a village, but the Panchayat Raj is allowing me only to construct G+2. Those guidelines also can be incorporated into BIM database, which is 10D, and direct implementation. So this is how we can, adopt ourselves to the building information modeling knowledge and what it can do. I've spoken about this. And even for demolition and renovation, also people started using BIM. How much I can renovate inside a building based on the 3D analysis? What are all the, you see, for example, today there are some tools available in Bentley. We are all aware of Bentley because Stab Pro comes under Bentley. In Bentley, there are certain tools in the name of context capture. So when you talk about context capture, what you can do, you can take the snapshots of a building, a 360-degree view, good image with good clarity and good megapixel camera. If you take the images 360 degree, come back, sit in front of a system, use context capture, and you can integrate with the photographs that you have taken, it will create a 3D model. From that, we can also understand what is the existing condition of the building. Do we at all require any renovation? If at all, if renovation is required, again, I can work on BIM. I can use BIM and see where all I can renovate and how it can be renovated, right? So this is in brief about that. Now, for all of us, for all of you who are part of this program, I would strongly request and suggest and recommend to look into Building Smart. So this is a worldwide authority driving the transformation of the building asset economy. It has got international standards and it will give the common language what exactly a construction industry is looking towards. I have spoken about multiple integrations, right? Now, this Building Smart will give common language to all of us. So this will be helpful in the collection of object-oriented modeling, parametric modeling, and structural modeling. So some of the terminology which we should use when we're adopted to, so most of us will get a doubt, okay, all these things are fine. Do we have any codes? So these are all some of the codes that will help us in using building information modeling. International Standard Organization ISO 12006 Part 3, ISO 29481 and ISO 16739. They talk about IFC, Industry Foundation Class. I spoke about it before. It exchanges the data and what are all the rules. IDM, Information Delivery Manual. Let us say L&T, Ramki, Nagarjuna Construction Company has to exchange the data. So this IDM will give the process of exchanging the data. And then IFD, this will give the international framework for dictionaries. Let us say, for example, I have created a door. Okay. So the door, I need to give one name. Let us say I gave it as D1.1 underscore IFC. I'm giving a random name, D1.1. If at all, if someone across the globe also creates the door name as D1.1, then it will say there is already an existing model which Kalyana had created into the database. If you are looking for a similar model, instead of creating another model, you can use it. If you want to change the configurations of that model, you are allowed to edit the existing D1.1. So that is how technology is growing today. So which means I can still take the existing I just said door as an example. It can be a wall, it can be a frame, it can be a floor or anything. So we have that flexibility to use it. And another thing is BIM collaboration format. Changing of coordinates. Whatever I used in Europe, or let us say I belong to UK, and someone in India wanted to use it. So I belong to India and somebody wanted to use it in UK. We can exchange the data through collaboration with respect to these international standards. Right. So what generally we do in BIM is, first of all, we have a pre-BIM process. So technology, process, and policy steps. So first of all, we need to see design, construction, and operation status in industry prior to implementation of BIM concepts. Then we take different objects and we create object-based modeling, model-based collaboration between two parties, network-based integration, and post-BIM. Once the post-BIM is done, it can be sent for analysis and design. So some of the examples of tools which we can directly use for closed BIM and open BIM are shown here. Revit to Revit is closed BIM. Edificious to Edificious is closed BIM. All plan to all plan. This is also one more interesting tool which we can use. Or if you wanted to integrate different vendors together, this is open BIM and the corresponding tools, right? So how this is done, as I just explained, one object is taken. So this is a column, this is a door, C means column, D is a door, W is a window. All three objects I have taken from the database and I used it for creating a 3D model of a building, right? You can see here. So these are all the options that I've got from the BIM database. So I have to pick one, whether I want W1 or W2 or W3, pick it and apply it onto the model, right? Similarly, this is one example of a facade, a curved geometry. Now, this is a detailed explanation of what we can do with BIM. We have already seen till 6D. So let us see individually what best we can do out of it for modular construction. So today, Government of India is also promoting precast construction like anything. There are many circulars that were released by Government of India through MORTH last year. Now they wanted to have the prefabricated units everywhere in the country, factories. Building information modeling can add a lot of value to existing modular and precast construction. That will add a lot of value, right? So one such thing, prefabrication, you need not do rework, accurate field layout. You can walk through the building and experience the building details, all of things. And 4D, it can do the project phase-wise scheduling, and it will give the planning for each and every step of construction, and it will optimize the dates also. Estimation and costing, it is so value engineering. So value engineering can also happen through BIM, as I spoke about it, quantity estimation and extraction. And then certifications. If a building wanted to get certified by IGBC or LEED or Griha rating, which is Government of India's initiative, it will help us what components of the building should be added to get IGBC certified. Let us say solar panel. How many solar panels are required for an entire building of area 4,000 square feet? It will tell us. Or how many rainwater harvesting pits are required? Whether the development area requires a sewage treatment plant or not. So it will suggest us depending upon our requirement. And then life cycle and facilities. So so for example, a BIM model was created for a hospital building or a hostel building or any building. BIM also will help us identifying at what points of time the building might experience the maintenance works and where all it can experience, what locations the maintenance works have to be done. So this is also something that is really interesting. And then 8D, preventing accident through design. This is what we call it as safe design suggestion. So tomorrow, if it can foresee, depending upon the dimensions and the loads applied, where all accidents can happen in a building and how to overcome that through risk analysis, right? So globally, this is what we can see now, where all the BIM is extensively used. Green color represents that those countries are extensively using BIM and the government mandated it. Orange color represents no BIM requirement, but they are in the process. Pink represents mandate. Policies are yet to be framed, but it was mandated. And then blue color represents future mandates fixed. So people started using it, but they're trying to make the mandates depending upon the future requirements. And the gray color represents BIM programs planned. So the entire globe is moving towards that. Currently, India is in between orange and gray. So BIM programs planned, and thanks to Indian BIM Association, it is headed by Dr. Amarnath. They are doing fantastic job in bringing out building information code from Bureau of Indian Standards, which we might see at the end of the year or the starting of 2024. Right. So now, when now we are going deep into parametric modeling now. When you take a new building and existing building, how can BIM help? So new building, availability of the pre-existing information model is not available. And what should we do? We need to create a new model. So this creation of the new model will help. And life cycle stages from inception, brief, design, and production. This is what BIM can help in new building. If it is existing building and the existing building models are already available in 3D model database, it will update the pre-existing model for renovation, for maintenance works like retrofitting. If it is not available, it will create the exact replication of the existing model through photographs or laser scanning or point cloud database, and it will be helpful in maintenance and deconstruction work, like for debris management also. So see how much it can do. That is really interesting, isn't it? So as I said, how each and every things are integrated, you can see on the screen. Every component is integrated to the other. That integration is nothing but the whole process. So I've taken an example of a column construction. So BIM, how it will help in column construction? It will tell us for the construction of column, we need rebar, formwork, concrete, and cladding. And for formwork, we need equipment, labor, and materials. And all these things will be again linked to LBS stage level based on the construction on the site. And how much time will it take? So design stage, take-off items, costing, take-off quantities and resources, and scheduling. All together, it will integrate. As an example, I have shown this, right? So you can see this here. I've spoken about Buildoid. So in Buildoid, once Buildoid is ready, it will go for analysis and then it will go for design. So these are all some of the softwares that are generally used for understanding the behavior. Yeah. So yes. So another thing is coming towards practical application. Now, this is what I'm more curious to show to you. In general, when someone is working on the site, you have to collect daily site photographs and send it to your project manager. And you have to have a model, and then you have daily site reports, bulk of reports. But if you are using BIM, see what will happen. You have a 4D augmented reality model, which you can display at a place wherever you are sitting right now. And what it will give us the information on construction was started in May 2024, and it has to go till 2019, and it will tell us the progress. What is the current status? I'll tell you. Yeah, so see this here. What is the on-scheduled construction that is happening? Ahead of schedule and behind schedule. So BIM will help us in tracking these things within fraction of minutes with just a model. You just need to feed it with the proper data. It will give the complete information. Another interesting thing is, so this is using mobile. See, at a construction site, there is an issue with the second floor window fitting. Now, one of the contractor has sent this message to mobile app, and see now what's happening. Live project overview at your fingertips. Delayed 0%, but the problem is 25%. So the project engineer manager is asking, what is the issue? Is it delayed or what? So here, parking lot delayed? No, it's not delayed. But what is the problem? Window fitting problem. So automatically, the person who is very good at window fitting, contractor, he will come and address the issue. Number two, less admin and more standardization. So let us say, for example, there is a chat that is going on between different employees of the company. How is it going on the site? Then they said, doing the concreting slab snagging. So see here, they are pouring the concrete. Now, what happened? Concrete slab snagging, meaning the two concrete layers were poured from two different pourings, and the levels are not adjusted properly. They have sent the images also. So then immediately, then and there itself, they were saying, reduce the slab by 20 centimeters to balance. See how fast this can happen. So another thing, record everything and prevent claims. So see here, there is a problem reported by a person called Alex Novak. So what did he say? So problem is associated with the floor tile installation. So what happened? Did we receive the tiles yet? No, not yet. We are waiting for over 24 hours. So this is the problem. So now to address this, immediately this message will go to the contractor who is looking after the tile. And he will say, the tile tiles are on the way. It is going to be received in next 2-3 hours. Now, is it not like our regular WhatsApp or Instagram or Facebook chats? That's how the BIM technology had advanced. You can see some great beam construction, task in progress. There is a problem here, task delayed, task completed. Some of the tasks were not started. If there is one task that is delayed, how much percentage it was delayed? 87%. If there is a problem on a scale of 100, 94%. Task in progress, 43% over, 57% pending. So everything is in our fingertips, right? Another interesting thing is it identifies overlaps in piping systems, fittings, MEP, and structural member. This is one interesting tool called clash detection tool. Let us say, for example, you have some dimension of the fitting which is overlapping with our electrical connections. It will identify, it will automatically suggest us where exactly this fitting should come, right? So this is another interesting thing with using of BIM. Of course, individual models. This is a complete federated model, but from this you can remove or you can analyze the architecture model separately, structural model, fire protection model, plumbing model, electrical and mechanical models. Everything you can bring out and combine together without classes among all these connections, right? So you can see step-by-step process. Whatever I'm showing is a stadium with seating arrangement. It's completely done through building information modeling, and you can see part by part. So step by step, without having any difficulty, it will take the entire process forward, right? So if you want to see the building life cycle through the building information modeling, from planning stage to operation stage, as I have shown you before, what this can do for us, right? And BIM also is directly implementable on the site. So let us say, for example, you have a BIM 3D model. It is reviewed by a draftsman, foreman, and it will be submitted to the BIM engineer to incorporate comments from the draftsman. And from that, BIM models ready for clash detection process. And then preliminary shop drawings and virtual inspection. The shop drawings reviewed by mechanical, electrical, or structural engineer. Final drawings submitted. Virtual inspection during installation. Now you can see everything is done through BIM, right? The process becomes very easy. If there are any clash detections, let us say pre-clash detection, and in clash detection, they have identified that some of the HVAC and architectural elements are clashing with each other. So that report will be generated and it will be sent through the team which is addressing the model updation. Model will be modified and then updated again, and then the pre-clash detection. In pre-clash detection, if they identify that no two elements are clashing, they are good for construction now. So I would also recommend this interesting document, which every one of you can go through for your reference. Project Management Book of Knowledge, PMBOK, fantastic book. It talks about everything that is associated with the construction and engineering, including the risk during construction. So this is one interesting document one can go through. Another interesting thing in parametric modeling is, so today we are living in a, like say for example, we are living in our own houses which are 20-30-year-old, where we have only plans in our A3 sheets or A4 drawing sheets. We need not worry. Today technology has gone to an extent where you take a 2D plan. In fact, our own students are using it at our university right now, thanks to our collaborators from Italy and in India as well, wherein we are getting a lot of support in development as well. You take a 2D plan in a piece of paper, just take a photograph from your mobile, upload it into one of the BIM tools which can convert. One such tool which we are using is USBIM, usbim.plan.ai. It uses artificial intelligence and it creates 3D model from a 2D plan And this is what you can see here. This is a 3D model developed from a 2D plan, which means lot of time is saved. You need not even create a plan also. Existing plan can be replicated into 3D. So this is something that we are also working extensively on with the help of our MTech and BTech students. It sounds really interesting once you start working on this. Now, the last part in the next 15-20 minutes, I will show you the importance of how this parametrical modeling will help in creating the nature-inspired configurations using two software called Rhinoceros and Grasshopper. Okay. So now the software name is Rhinoceros. So Rhinoceros is a 3D modeling software like your Revit architecture or 3ds Max or SketchUp, but it has got a lot of flexibility in creating a model. Grasshopper is a parametric model, a parametric tool. It uses circuit diagrams to change the configurations to whatever shape we want. Rhino is a 3D modeling software. Grasshopper is a parametrical tool that we can use. So once we install Rhinoceros, Grasshopper will be added as a plugin and we can start playing with it. Right? So let us see, for example, if you see this Grasshopper tool, we have to create a cylinder with initial parameters. So for cylinder, what do we need? We need XYZ coordinates. You can see here, this is the Grasshopper circuit diagram. This we have I've taken a snapshot from the model. XYZ points we will specify, and we have to interlink with the cylinder. For cylinder, what do we need? We need the radius, we need the length. We specify it here. So what do we need? Radius of 75 mm, length of 500 mm, and again, points with respect to XYZ. Once I define, I got a model. So using parametrical tool, I can create any model of my choice with any maximum amount of complex configurations also. So you can see here, two cylinders were created. So one cylinder was created and I copy pasted it in another direction. So two cylinders, I can see another advantage is you all can see this 1000 point and there is a diamond symbol. Once I start moving it with my cursor in the software, this 1000 will become 500, 500 will become 200. So which means the size will automatically change and you can experience it live. You need not wait. The moment you change the size, it will automatically be reflected where you can take a call on whether the dimension is sufficient or not. So like that, you can create number of columns required for a bridge construction. On the top of it, you can create a complex configuration. So this is one complex configuration created out of Grasshopper circuit diagram. Circuit diagram means it just gives us the basic thumb rules for us to create a model. Manuals are available. It just uses the basic functions with respect to set theory, probability theory, point, coordinate systems and all. I have shown you CSG geometry, like constructive solid geometry models previously. This uses the similar concept. So the same three models which were created by this step-by-step process, these algorithms are used. Slowly we can change the radius. See, number of counts are 16 here. 16 meaning there are 16 gaps that are provided. We can reduce it, increase it. Radius can be increased or decreased within fraction of milliseconds. Right? So this is how a 3D model was created, and there is one example that you can see a 3D model of the same thing was created, whatever we have done experimentally. On the top of it, these are some of the parametric models. So today in the house, we wanted different architectural components that we wanted to use in our building. So a decorative table or a stool or a chair or a bench inside the house, you can create your own configurations for your interior components of a building and play around with that. So this is also one more example of parametric relationship. And see this building. This is completely designed, architecturally designed using parametrical tools, because conventional software, it's not that easy to create this shape. Right? You see here, this is the final shape that we are talking about. So this is coming out to be really interesting. Lot of research. BIM is not only about modeling and teaching. We can do a lot of consultancy using this. A lot of 3D models can be created and a lot of research can be explored, and I'll show you some of the interesting research problem statements. So this is some of the work that we have carried out at Mahindra University in the last 8 months, developing nature-inspired architectural configurations through parametric modeling. Thanks to one of my BTech students, Mr. Hari Prasad. He is the one who is responsible for this presentation. He has done a wonderful job. So this is what we have done. So what we have done is we wanted to create lattice and cellular type patterns which are close to nature, meaning honeycombs, plant tissues, cellular designs, and which offer excellent mechanical properties once they started using it. So now what we thought of doing, we wanted to create a 3D model which are nature inspired and 3D print the polymer for the shape which we have created. Okay. So for that, this is what we have done, develop nature inspired and integrate 3D building information modeling through to a 3D printable model. I'll show it to you how we have done. So for that, we have used rhinoceros and grasshopper along with 3D printer for 3D printing this object. So this is the whole methodology that we have followed. We have first architecturally designed the lattice structure based on the configurations, and we determined lattice parameters. So what are lattice parameters? Size, shape, and spacing of each of these things. And then preparing the 3D printing processes. So create a 3D model, material and printing environment should be created. How many layers should be printed and what is the layer thickness and what is the material used for printing. Okay, so and then printing layer by layer and monitoring the layer by layer printing. And then post-processing. So post-processing is, before going into post-processing, whatever the building information model which we have created, we converted it into a CAD model. That CAD model will be used for slicing. So once we sliced, the post-processing is done and the 3D model is ready. Then we have, of course, some confidential information I could not share because we are working on a project on 3D printed concrete as well as 3D printed models. So these are the models that we have got after applying it in grasshopper and rhinoceros. So see how many cellular type configurations we have created on the screen. And then we have, so this is the whole code in detail that we have adopted for creating these 3D models. You can see this also. One is honeycomb mesh. So once this mesh is ready, we have created a 3D developed lattices. This is called a Vintile lattice, and this is called a square lattice, and a Voronoi 3D lattice, honeycomb lattice. All the 3D models are created, and then we started printing it using a polymer. So you can see here, this is the 3D model that we have developed using BIM, rhinoceros and grasshopper. And by using a 3D printer, we printed it to see the exact shape. We have another purpose of how to use it, which I can not share right now because it's confidential right now. We wanted to use it for some applications in concrete also. So this is another shape, Voronoi shape, wherein you can see the 3D model and the 3D printed model. So we have used this 3D printer and developed the 3D models corresponding to it. So last part of my presentation, how to integrate in the next 5-10 minutes before I take up any questions, how to integrate building information modeling with 3D printing. So you can see any CAD model, whatever we develop can be converted to a 3D printing. So when we say 3D printing can be done for multiple materials. Today trending is concrete 3D printing. Even we are also having one 3D concrete printer, and one of my students is also doing his PhD on that. Now we are going to a next level where we wanted to explore the interlinking between BIM and 3D printing. So that you can see here, it's called as prototyping, layered manufacturing, or additive manufacturing. So you can see this is a CAD model, and this is a slicing of the model, and we are squaring the edges of the model, and then stacking each and every layer, physical prototype and finished physical prototype. So CAD model and finished physical prototype should look exactly the same. So there are many 3D printing equipments that are available in the market. Multiple parts can be created, multiple tools can be created, and on the top of it, it's various. See the particle size that we are seeing here, so small, and it's really interesting. We can print. In fact, in our campus, we have printed 3D printed Ganesh, 3D printed Lord Krishna's idol. It's like kind of many configurations we are trying to print. Now we started working on developing models for polymers. So these are some of the shapes, geometric configurations, how easy we can print it. There are different types of 3D printing, polymer 3D printing, fusion deposition modeling, and there are many other things. So currently we are using fusion deposition modeling. Any engineering college can get one 3D printer, which is 1 lakh, 2 lakh cost. Use BIM tool. This is my sincere suggestion and request also. You can buy a small 3D printer, use a 3D modeling CAD tool, integrate both of those things, and you will see wonders, right? So I'll not go deep into it. So what it does, fusion-based 3D printed modeling, you can see this is the nozzle that will print. So once this nozzle starts printing layer by layer, you can see the fusion at a temperature. Once it has to be heated till some standard temperature as per norms, once it stabilizes at the temperature, this is in a liquid form. In liquid form, it will take it, it will heat it, and it will convert it into a kind of a semi-solid. And this semi-solid will start printing with respect to a filament at each and every layer. So we need to ensure that each and every layer, it has got good stability between layer to layer. If the stability between the layer is lost, then the consistency will be lost in the printing, and the whole model stiffness and strength will come down. Those are some of the challenges. So this is our first initial model which we have 3D printed. We got inspired from tall building concept. So you can see here, this is a tall building 3D demo model and the 3D printed model also with multiple. This is a 3D printed model using ABS plastic or kind of a polymer. And you can also see the applications of 3D printing, touch and feel. You can create your, our daily routines can be 3D printed. I can strongly say that, very much strongly. Patterns of casting, molds for casting. It's kind of pretty much interesting for us. You can, it's a trending thing. You can gift a ring to your partner. You can gift a ring to your friend. You can gift anything of whatever configurations you wanted to try. For tooling in mechanical applications, it can be used. Reverse engineering. I have created a model. I wanted to reinvent it. I can still do it using BIM and 3D printing combo. And biocompatible materials, you can see the skull of a human being was modeled using a 3D printer, and after modeling it in 3D BIM. Medical application has got fantastic thing, and mass customizations. As I said, there are many materials which we can use for printing. And there are some of the test objects, and you can see on the road, we will have these, traffic signs, poles and everything. You can start printing it. Pendants can be printed, traffic cone can be printed, what not. You have a configuration in mind, you can print it. So last two slides before I end. One interesting thing is 4D printing also. The difference is, in 3D printing, we have a material and static structure. But in 4D printing, smart materials also can be. So it will monitor the behavior through intelligence or smart nature of functioning of a material. Meaning, it will tell us the functioning of a material that was printed throughout its lifetime, right? That is 4D printing. Now, for all of us, whoever is interested in taking up projects or research or PhD or at BTech level, MTech level, the construction side of the future is going to look like this. Everything is connected, collaborative work between the workers. Even the material also will be designed based on sustainability using BIM. Delivery will happen without any hurdles. Site sensors were installed to safeguard the people working on the site and equipment falling down suddenly. Everywhere it is sensor connected. Now today we could see even the sensor-based jackets were installed, wherein the movement of the worker on the site also will be monitored on a day-to-day basis, hourly basis. That is where we are living in. And finally, to conclude this presentation for all of you, actually there is one more topic on integrating artificial intelligence to BIM, but due to lack of time, I have skipped it. But if anyone is interested to take up research on this specific topic, 5 fields are there. 2 of them we are already working. 3D printing applications for BIM, drone utility, cloud collaboration, Internet of Things and applications to BIM, and augmented virtual reality. So thank you all for your patient hearing. I would also like to sincerely thank the organizers for meticulously planning this event. If any one of you have got any questions, I will be more than happy to answer. And if anybody wanted to write to me, talk to me, work with us, associate with us, you can see the screen here. I'll be more than happy to, you can write to me. I'll be more than happy to address any of your issues. So if you have any questions, you can unmute yourself and you can ask any questions of your choice. You can unmute yourself. You're allowed to unmute. Thank you. Or you can raise the hand. There is one question by Devender. Is 3D photo printing part of BIM or require any other special software application? So 3D printing of a model is done through BIM. And for 3D printer, from whatever the source you are getting the printer from, they'll be having their own software. One advantage is you can convert your BIM model to 3D printable model. You need not sketch it separately. That's one advantage. Any other questions? You can unmute and ask as well. I'll be more than happy. Yeah, thank you so much. Rajesh sir, are you there? Hello, Rajesh ji, can you hear me? Okay, so anyone, meanwhile, if you want to interact with me, you can unmute and, okay. Oh, sorry, I'm sorry, there is a break in my voice. I'm extremely sorry for that. Okay, if anyone has any questions, please unmute yourself.
Yeah, good morning.
Yes.
Actually, I have a doubt. Is there any software? I being a structural engineer, I give 5 bars of 12 mm, 8 bars of 14 mm. It arranged by itself. Such softwares are there.
Yeah, so the thing is, currently, with respect to detailing, we have RCDC, where it will directly give the detailing as well. I hope you have already explored it. Now, if we wanted to directly get that in 3D, you have to manually give it with the least efforts. Directly available tools will not be more ideal in terms of accuracy. That's what I figured out based on what I've experienced.
Your lecture was very informative and very good. Thank you.
Thank you so much, ma'am. Any other questions from anyone? Yeah, thank you so much, sir. Okay, sir. Jagannatha sir, if you have any questions also, you can. Yes, sir. Thank you so much for your appreciation, sir. Good to see you here, sir. Dear participants, any other questions? Rajesh ji, can you hear me? I'm just trying.
Yeah, sir. Well, it was very informative session, sir. I think there is no doubts in YouTube's while we are streaming in YouTube also.
Okay.
Yeah, sir.
Yeah, last couple of minutes, if anybody wanted to ask any questions, or maybe Rajesh ji yourself also can ask. If you have any questions from anyone, I'm more than happy to answer. And I'm also posting my email ID into the WhatsApp, chat group, chat here in the Zoom. If anybody wanted to write to me or talk to me, maybe you can write to this email. I'll be more than happy to address any of your concerns associated with BIM or any ideas associated with BIM.
Okay, sir.
Okay.
If you want to buy the software, how much it costs?
I can suggest you one thing, ma'am. Please write to my email ID, and maybe we can discuss personally, and I'll share all the financials associated with it and what tools are best to be used in the current market.
Okay. Thank you very much.
Thank you. Okay.
Okay, sir. Thank you, sir.
Thank you so much. I'm making you host, and I'll be leaving. Just a second. Okay. Thank you so much, all of you. Looking forward to see you all in further sessions.
Yes, sir. Thank you, sir. Thank you so much, sir.
Thank you.
Okay, dear participants, we'll send you the feedback form in WhatsApp group and also to the respected mail IDs. Hope tomorrow we'll continue this session at 11 o'clock. I hope you are all getting mails regarding feedback form. Okay, thank you. Thank you so much for your cooperation. Thank you. Dear participants, we have sent the feedback form in group chat. You can go through and submit the feedback form by 4 o'clock. Today evening 4 o'clock.
Hello, sir. Hello.
Yeah. Tell me, sir.
Please send the feedback form in email also, respective email also.
Yeah, sir. We are sending
because some due to technical reason I could not able to join my WhatsApp group. But anyhow,
okay.
I'm having WhatsApp and I'm using it. But if possible, you please add in my WhatsApp number to your group. Or if it is not possible, anyhow, you please send through email.
Okay, sir. Okay, sir. We'll send you the mails.
Please take care of, please. Because
okay.
You said within 4 o'clock, within 4 o'clock, you have to submit the feedback. So please, right now, please send it, please. Thank you. Thank you.
Yes, thank you.
Remaining 3 days also, you please take care of us. Okay, thank you.
Okay, sir. Okay, sir. Thank you.
Thank you, Professor. Thank you.